Say I want to make a list of 20 random numbers from 0 to 1. Well, first I have to tell you how to get a random number from 0 to 1. And for those specific values, it's easy. I just do this random real command. And if I want to verify that, I can look up the documentation. So if I don't give it any inputs, just do random real and then empty brackets, then that gives a random real number from 0 to 1. Okay, they call it pseudo-random just because there's no way to literally make a random number inside of Mathematica. So that's how I make one. How do I make a list of 20 of them? Well, it's pretty easy. I can make a table. And one way of doing this that I haven't talked about yet is, since the left-hand side of the comma, since that doesn't depend on a variable name, I don't actually have to put a variable name here. I could do I, 20, but works just as well to do 20 inside these curly braces. Okay, so there's 20 random real numbers from 0 to 1. And you might ask, is there a faster way to do this? And this is related to why the video is titled Immediate Assignment versus Delayed Assignment. So let me try to write this in 2 lines instead of just 1 line. So let me do A equals random real, and then make this table, and instead of having random real in there, I put A. Lots of times it's good to segment the code like this, so that it makes it a little easier to read. So this obviously didn't work, and what's the problem? The problem is that here, A got defined to be some specific random real number, and then that specific random real number, this 0.540289, that got repeated in here 20 times. So let me run it again. It's still going to be the same number 20 times, but it'll be a different number. Okay, so here the number that was chosen for A is 0.83, ... And so now that's in this list 20 times. So this equals here that we've been using so far, this is called immediate assignment. It means that it chooses a random real number here, sets that to be equal to A. There's another one that's going to be very important for us, especially when we're doing random walks, and that's called delayed assignment. And the way I get that is by putting a colon in front of the equal sign. So what that says is, don't evaluate it now, but every time you see A, then evaluate it again. So for example, let me run it here. So the first time it saw A for the first of these 20, it got this random real number. Second time it saw A, it chose a new random real number, and so on like this. So a very natural question is, how are these random real numbers distributed between 0 and 1? Well, I can try to get a sense for this by putting it inside a histogram. So let me call this, how about my table? And then let me do histogram, my table. So I don't learn much from this, but what if I do more instances of A? What if I do 200? Okay, I still can't really tell what the pattern is. There's 2,000. What about 20,000? What about 200,000? What about 2 million? What I'm trying to demonstrate here is that these random real numbers from 0 to 1 that are being chosen, they're chosen to be distributed uniformly from 0 to 1. So any value in 0, 1, that's just as likely as any other value from 0 to 1. And a cool thing that we can do, let me go back to a smaller number, let me go back to 20, is let's look at how is A plus A plus A distributed. And you might think this is the exact same as 3A from your algebra knowledge, but it's not, because this A is a random real number, this A is a different random real number, this A is a different random real number, whereas if I had 3 times A, then that would choose a random real number and multiply it by 3. So that's something that's different. So yeah, let me go back to my A plus A plus A. So again, I can't really see what the pattern is. Let's go up to 200. And let me go all the way up to 200,000. So you can see that I'm getting this normal shaped curve. Okay, this bell curve. And it's really interesting in statistics and probability how often this shape of a curve shows up. So all we did here was we chose 3 random real numbers uniformly distributed from 0 to 1. We added those 3 numbers up, and then the distribution of those sums of 3 numbers, that followed this shape. Okay, whereas on the other hand, if I do 3 times a, okay, then it goes back to looking totally uniform. So what was the key idea to get out of this video? The key idea was the difference between this colon equals and the regular equals. So let's just go back and look at it one more time. Okay, so let's just go to 200 of these. Let's do a 200 times. With colon equals, with delayed assignment, this is what it looks like. Okay, 200 different real numbers. Whereas with immediate assignment, let me take away this semicolon. So this line here, this corresponds to this one, this assignment of a with no semicolon at the end of it. And then this line here, this corresponds to putting that single number into a length 200 list, putting it in there 200 times.